retrieve the information, whatever specify the input is given, whether data is valid or based on the given information of the corresponding for the clock input. You go for the connector for FPGA device, you connector for the FPGA to keyboard to FPGA device, what type of data is given to the connector for the corresponding FPGA device. So generally go for, we connect for keyboard connector to the FPGA device. So these are the timing diagram represented for the PST gate for. Actually working for the information along with some additional bit also will be transmit. Okay, by giving for the corresponding key or press, they go for transfer the FPGA device. How to communicate the corresponding FPGA device as well as the corresponding keyboard means you are sending the some form of the data format. Okay, so first you consist for keyboard, suppose you can for any type of suppose you can consider for A and the key. You press, you are equal to some comma scan go or transfer to the FPGA device. The scan codes along with this scan code representing for the corresponding go for the data information along with some additional bit will be considered. Okay, so totally you are connect for the single key press, you go for the keyboard through the FPGA device, you go for 11 bit of the information will be transmitted. So the 11 bit means we consist of, so first bit represent go for the corresponding go for idle bit. So this idle bit means without any information will be transmitted. So next you are consider go for the stop bit, whether this is given key is pressed with, whether information transmitted through the keyboard to corresponding for the FPGA device. This indicate for the corresponding for starting bit. So next actual what's the information key or press you are transferred through the corresponding for the FPGA. This is represented for data information. This data is corresponding for the 8-bit information. So last one you go for the parity bit. So what is the purpose of this parity bit? Whether the key is pressed, whether it is either direction or correction you checking based on equal to parity bit. Either go for odd parity as well as the even parity. Now I am using for the another odd parity bit. The last one is go for the stop bit. Whether this key is pressed, the process will be over. But indicate the corresponding equal to stop bit. Okay, you go for the clock information. You go for either for rising edge as well as the falling edge. So given data information is valid for the corresponding to the keyboard to FPGA device, only is based on the equal to where indicate go for the trailing edge of the device. Only for based on the each of the trailing information you are corresponding for the key information will be retrieved. Suppose go for falling edge, rising edge is not will be considered. So what type of frequency is operated? You will be considered only for based on the trailing edge of the information based on the according to data will be transferred to the keyboard to corresponding for the FPGA. This is the first module you are describing for the corresponding keyboard interface to corresponding for the FPGA device. So this is a corresponding PST keyboard layout. So corresponding suppose A key concept of scan equal to 1C. So equal to go for you are using for the Tamil standard, you are using for Tamil 99 standard. So corresponding A is key is equal to for Tamil, you are assuming for consider as a R. So corresponding go for R, you consider for the some other cases. Based on the Tamil 99 standard, your interface corresponding the keyboard interface corresponding for the FPGA device. So this is previous two serial circuit schematic diagram. So you go for already told that you get the two signal you transmitter. One go for data information, another for the clock information. So this is a PS2 date, PS2 clock. So both will be interface with the corresponding connect for the connector of the corresponding FPGA device. So next module we are discussing for the corresponding for the SD card to corresponding FPGA. Okay, what is the purpose of this SD card? How many pin is available in the SD card in the FPGA device? So SD card we generally go for 9-bit device. We control for the data as well as the CMD, then corresponding for the clock information along with the some inbuilt you control some controller as well as the some memory organization. So what is the main purpose of this SD card is represented to secure digital device. There is a highly integrated flash memory device with a serial and random access capability. So okay, you are connected for interface with the what type of speech out is spelled out in the corresponding device. The information will be created for the database. Okay, the database will store the all the phonetic form of the corresponding for the speech output in the Tamil language. Okay, so given information you are given for store the some format. You are go for our you are using for the dot base. There is a wave file format. You have store the data of the corresponding speech output in the form of the wave file format. format. Okay, just go for correspond key were recognized, we correspond to FPGA device. The FPGA device is what type of key or what type of speech output you are playback in the correspond device. The whatever there is a wave is all the information is present for the this corresponding SD card device. So the SD card was a different types of format. There is a different protocol using or using for SD1 protocol will be using. There is a synchronous series protocol with one data line used the bulk data transfer, one clock line for synchronization and one command line used for sending for the command frame. So another way protocol say go for ST3 protocol as well the ST4 protocol are using. So next another module, third module for how speech output were playback in the corresponding interface of the FPGA device. Of a third module you are described for FPGA information, you go for playback with the corresponding for the codec information. So what is a codec? Is a test equipment for other modules and also input output for the audio system. Okay, so go for playback the key, you go for simple press for the A and the key, then go for FPGA device. This A key or correspond enter the FPGA device, go for the corresponding scan codes. These scan codes retrieve go for the SD card, whatever information audio file will be present. This is in SD card, you are present only for address of the information. Of FPGA device, read the information to the SD card, you go for corresponding EA, whatever information will be playback, then correspond read the address, then again go connect to the codec. The codec function, these go for only for playback the corresponding whatever information we playback, they go for playback the corresponding the audio output. These go for codec, we connect the interface with the some. The connect to this from speaker module, the corresponding information key is present, we automatically transfer the corresponding of the FPGA device through the audio codec. You are using for DU1 board, you are using whatever audio codec standard you are using, then WM8731 control, you go for serious I2C bus interface. That is I2C represents for inter-integrated controls. So based on cyclone to FPGA whatever, you go for the interface with the audio codec through the WM8731s. So these are the structure of the audio codec connected with the corresponding FPGA device. What type of information clock information we needed, you go for S clock, S DAT, then X clock, there is ADC, CLRK, ADS, DAC output. There is a DAC, go for codec also the present for, you consist of for the given analog if convert digital as well as the digital input convert for the analog output, you play by the corresponding output. So both the devices we require for the some clock information as well as some data information. So these are the some interface signal, you presently write the coding from the NIAS2 processor where implement the corresponding audio outputs. So next last module you go for how to syllabus you are recognizing the corresponding display in the corresponding output. Whether you key is pressure, whether the output is getting the speech output, on the same time you are displaying the what type of character be press, you are displaying the corresponding output. So you are using you go for the TFT. This is a thin film transistor LCD display. So these are the advanced technology, you go for display the what type of character information in the corresponding in the LCD displays. So you are using the TRDB LCM kit provides everything you need the developed application user digital panel on the Altera D2 and D1 board. You develop LCD controller and also display the Tamil text in the form of the TFT LCD. These are the corresponding interface device. Corresponding is a FPGA processor. You connect with the TFT LCD device. Interface the corresponding what type of information key is present. Automatic transfer the corresponding for the corresponding display device. So what type of algorithm you are proposing in the corresponding system is describe the proposed design flow algorithm. So first initially whatever again first I go for load the acoustic library. This load the acoustic library means corresponding what type of wave files you have playback the corresponding output, you correspond load in the output. So next what type of key information we press. We load the target or input word inside the counter. When the target count initialization, the loop is created. When playback audio codec the corresponding memories. When playback is 1, the audio codec out will be stopped. That is why you are continue for the remaining process.